Hello, good evening, everyone. Today we are going to have a open session for week 4.
Good evening, ma'am.
Good evening. Okay. So, is it visible to you?
Yes, ma'am.
Okay. So, let's start. So, in week 4, we have introduced continuous random variable, right? I hope you may have watched the lectures for week 4.
Yes, ma'am.
Yeah. So, we will continue with that. So, what is continuous random variable? Whenever we have any event or experiment at that time, we describe on that particular experiment a random variable which will take some value, and we observe their distribution, and then we proceed further for analysis, right? So
Yes, ma'am.
we have seen discrete random variable. Now we are moving towards continuous random variable. So before introducing definition for continuous random variable, one thing is necessary, that is CDF. What is CDF? Full form, anyone?
Commutative distribution function.
Cumulative distribution function. Fine. Yeah. So because just a minute. Okay. Yeah. Aren't they able to join directly? Okay. Yeah. So, yeah, before introducing continuous random variable, we need to have knowledge of cumulative distribution function. If we go by word also, at that time also, there is a word cumulative, which makes some sense, right? That means all the whatever happened till now, we have to cover up all that things also. Whenever the word cumulative is there, cumulative distribution function. So for time being, you just consider it as a mathematical function which follows some properties. Then we relate it with probabilities and random variables. It says that for every CDF, there is a sum of the random variable is there. There exists some random variable for that. Okay. So for CDF, we generally denote CDF by capital F of X, right? What is CDF? So it is a function for some random variable X. Let's say it is a function for some random variable X. Variable X, which is defined from R, like whole real line to 0 1, that is closed interval 0 1, 0 1, which satisfies some properties and is defined as generally, if it is a function, then there might be some definition, right, for that
Yes,
function.
ma'am.
So definition is fx of x is equal to probability of the random variable taking all the values less or equal to x. So this is a kind of function which is generally a like it's always continuous or piecewise continuous, and as x approaches to infinity, that means this small x, your random variable will take some values, right? It has some range.
Yes, ma'am.
Yeah. When your x approaches to negative infinity, this CDF should go to 0. Then
Yes,
your fx of x should go to 0. Why it is so?
ma'am.
Goes to
Because
0.
probability will be, I mean, close to zero.
Why? Probability close to 0, that means
I mean, uh, like,
hmm, probability going to 0. That means probability that x is less or equal to negative infinity. That means it has to go to 0. That means the occurrence of event is not yet done. Like for example, if some outcomes, you have performed some experiment and the outcomes of the experiment starts with, let's say, that means your random variable, uh, the range for random variable is negative 500, and it starts taking values after negative 500. So once your x approaches to negative infinity, the definition for CDF is that it is probability of all the x which is less or equal to this small x. So once this is negative infinity, or a number which is not taken by random variable, your CDF will be 0 at that point, right?
yes, ma'am.
Did you get? Let's say your random variable is taking value, uh, range for this random variable is from negative 500 to, let's say, 500. Okay. At that point, if someone asks you what is the PDF, what is the CDF for x less or equal to negative 600, at that time, how will you go for it? Like,
Zero.
it will be definitely 0, right?
Yes.
So if it goes to negative infinity, at that time also it will be 0. Fine, like that only. This is
Yes,
one
ma'am.
of the property that if you are defining CDF, then this should be like that. If x is taking negative infinity, the CDF, your function, should approach to 0. And if x approaches to infinity, at that time, this
Function
fx,
approaches to one.
yeah, it approaches to 1. It will always take non-negative values. Sorry,
Yes.
not non-negative. Yeah, non-negative only. Why it will take non-negative? Because in definition itself, we told it as the range for this function is 0 to 1 only. Okay,
Yes,
fine.
ma'am.
Okay. And the one special thing for this function is that it is always non-decreasing function. Fx is a non-decreasing function.
Yes, it will continue to increase
Yeah, it will never
as
go
we are
down.
adding
Why?
the probabilities.
Yeah, because we are adding probability, so it will never decrease. Fine. Okay. Function. Fine. Non-decreasing means it may be possible that sometime your CDF will look like a stepwise function, but it will never decrease. It might be like something like this is, if this is 0 and this 1 by 2 and this is 1. At that time, It may be possible that your function is taking from 0 to 5, it's taking value 0, your CDF function. And from 5 to 10, your function is taking, let's say, 1 by 2. And 10 onwards, it will take 1. What does it mean?
That probabilities of all the values of x till 10 is 1.
Yeah, that means if you are interested in calculating probability that x is less or equal to 11, then what it would be? It will be 1.
1.
Why it is so? Because we will add all the probabilities of all the numbers which are before 11, and it's 1 only. Okay. So,
Ma'am,
yeah,
this continuous random variable, this CDF will be always a continuous. No, there is a jump in the, I mean, that graph what you have drawn.
yeah, that is for continuous random variable. I am just introducing cumulative distribution function. Cumulative distribution for continuous random variable will always be continuous. But in this particular case, it's not a continuous case where I'm just introducing a CDF, how it will look. It will always increasing. That was the purpose for this example. We have just started only cumulative distribution function, because for to define a continuous random variable, we need the base of CDF. That's why I started with it. Okay.
Okay.
Okay. So observe one thing here. It's not a continuous function. It's a piecewise continuous. But the thing is, once it increased, it always increased. Either stable at 5 to 10, but not decreased. Fine. That is one of the property for cumulative distribution functions. Okay. Then come to continuous random variable. So yeah, anyone, if we want to define what is continuous random variable and how it should look like, then how it would be?
That is a continuous, I mean, the probabilities take values over a range of elements. I mean, over a range of random variable. Say for we can define probabilities on x equal to 0 to 1 or 0 to 3 or 5, but we cannot define probability at a single point.
Okay.
Suppose x is equal to 1, so there the probability is 0. But for a range of for a range, we can define a random variable. I mean probability for
Yeah,
continuous
that is
random
one
variable.
thing. But when it comes to define a continuous random variable, at that time we will say, okay, if there is any random variable that we have defined, let's say we had an experiment and we have defined a random variable x, okay, and which has some CDF fx of x, which follows that rules that we defined above, right?
Yes.
Then at that point, let's say there is a random variable which has some some CDF. At that time, this random variable x is said to be continuous if what? If your fx of x, that means this CDF is continuous at every point x that this capital X attains. Then okay, so
Yes, ma'am.
if we have defined random variable x and its CDF, then x is said to be continuous if your CDF is continuous. Okay. Is there
Yes.
any doubt regarding this?
No, ma'am.
Okay. If your CDF for that is continuous, so sometimes if graph for CDF is given to you, at that time also you can decide whether your random variable is continuous or not.
Yes, ma'am.
Okay. So for that purpose only, I introduced this example where if this kind of graph is there and they are asking about whether your random variable x is continuous or not, and there are some 4 or 5 options, at that time you can discard this kind of options because this is not a continuous graph, right?
Yes.
Okay. So going with some like okay. Once we said our CDF is a continuous function, that means there should be no jumps in the graph, right? There will
Yes.
be no jumps in your graph, no jumps or steps, whatever you say. And what other we can say? Like if you yeah, if you take any interval, okay, if you take any interval for x, let's say x is lying between a to b, then this closed interval AB is an interval, right? Fine. If you choose
Yes.
any interval, then it should give,
B minus A.
yeah, B minus A or what? Probability
Your
for, yeah, is equal to f of B minus f of A. Okay. This is somewhat you may have seen in your in these lectures again and again. Can anyone explain the meaning of this expression? What does it says to you? Probability that x is, yeah.
It is the area from the lower bound to the upper bound.
Okay, but let's say you have an event, you have some data, and after that only this thing has come, right? So,
I'm
eh,
here.
what does this mean?
I'm here. It should be A less than X. No.
Okay, okay. But it's a continuous, right?
Ah, yeah.
Yeah, x is continuous, so whether you include a or exclude
Does not
a
matter.
doesn't matter. Yeah. Why it is so? Because one more thing is there with continuous random variable and CDF, that probability at any particular point is
0.
0
Yes.
for every x, right?
Yeah.
Yes.
Okay. So inclusion, exclusion doesn't matter, but I'm asking you, what does this expression means to you? Like,
Ma'am,
what
that
will you
means
illustrate from this?
the cumulative frequent. I mean, sorry. Um, the CDF of x x less than equal to b, sorry, x is less than x greater than equal to b, uh, subtracted by CDF of x less than equal to x greater than equal to a, gives
Okay,
us
okay,
the,
that's a mathematical thing. I'm just asking if x is a random variable and you are writing this expression, then what does it mean? See, in statistic course, we have seen distributions, probabilities, and all these things. Whatever we have learned is all about what the experiment was done, what the event would occurred, right? In that
yes
sense,
ma'am.
what does it implies this expression? This is nothing but the probability that your x is, see, x is a random variable, right? So it will
Yes.
take some values, and this is a continuous random variable, and let's say x is taking, so x will take some values between a to b, this closed interval a to b, okay, or it may take all the values, the range of x may be the whole r, right? Out of this whole r, what is the probability that your random variable x will take values between this interval a and b? That's what we are
Yes.
calculating with this formula.
Yes ma'am.
Okay, got it?
Yes ma'am,
So
got it.
what is this? This is nothing but the probability that your random variable will take values between this given values a and b, and how it is calculated, how it is being calculated. So using CDF function, you are calculating it, f of b minus f of a. Okay. So
Madam, one
yes,
question here. Sorry. Just px is equal to x is equal to 0. You have written
yeah,
probability. So that is understood. But in some of the problems when I do na, so for example, px is equal to 4. How they calculate p is x is less than equal to 4 minus p x is less than 4. So the
Like this.
uh,
Just a
x
minute.
is
Probability
equal
x is equal to 4. They write it as
to p x is less than equal to 4 minus p x is less than 4.
okay.
So but it will not come as 0. Sometime it is come as a point 0.6 point like that. So why it is so different? Like some here it is every time you have told for x is equal to 4 it is 0,
Mhm.
but here there will be some value. So
Okay, okay. So just check in that particular question if x is a continuous random variable or not. Okay.
okay.
And why they do like this? I will explain you. Whenever you are not sure, or in the question it is not given that your x is a continuous or discrete, but they are asking you what is the probability x is equal to 4, and they have given you CDF function. Okay. So
Yeah.
with this particular with this data, you can calculate probability x is equal to 4, okay, using this formula. But why are you using this formula? Did you get why this is correct to calculate this probability x is equal to 4?
No, I was confused because I think at particular point it should be 0, like how you told.
But if your x is a discrete random variable, at that time it is not.
Okay, okay.
See,
So in the
this is
question, if it is not mentioned, then we cannot. Okay,
directly claim to 0. Yeah.
okay,
Let's say if someone is asking you x is a some random variable, okay? Okay, I am asking you x is a random variable, okay?
okay.
And just a question is, okay, this is a random variable, then calculate probability x is equal to 4,
Yes,
okay?
yes,
Probability x is equal to 4, and I am giving you some CDF,
yes,
okay? Let's say your CDF is f of x and it's known to you, okay? It's some value, some
yes.
function is there, then just calculate it. With this information, you are not sure whether your random variable is a discrete or a continuous. If it is continuous, then no need to know about this. You can directly claim it as 0. But
Oh,
let's say behind the scene, you come to know that this experiment was nothing but the throwing a die.
yes.
At that time, what will be your probability? Will you claim it at 0?
No.
No.
No, right? At that time, you will say, okay, it might be 1 by 6.
Yes.
Okay. So it matters what the context is.
Okay.
Okay. So let's come to this point why they are writing like this. If you have CDF is known to you, and you want to calculate probability at some point where you don't know whether your x is a discrete or continuous random variable, at that time just go with this formula. But why? Let's say this is a real line, okay, negative infinity to infinity, 4 will be
Because
somewhere,
yeah,
yeah.
because this gives the jump. Like when I was seeing one for example, 0 to 4, there will be one value like point 0.2, and at the 4 also there will be point 0.6 also. But
Sorry, sorry. What, 0 to 4?
like in one of the question it was mentioned
Hmm.
that yeah, if you can draw one step na,
Yeah.
so from 0 to 4 maybe some step, and
Hmm.
from 4 above 4 there will be one, yeah, yeah, if one more step above,
Above to 4, not connected, right?
not connected, yeah,
Like this.
yeah, yeah. So
Yeah.
then this expression will give the jump. This expression will means I am not
Hmm.
sure, yeah, this thing we
Hmm.
want to calculate,
Yeah.
uh, yeah.
Yes, yes. If your graph was looking like that for this particular example, at that time, this is absolutely correct.
Yeah, but one question here. But if whatever you made, na, But in the function, like there will be some ranges given, like from 0 to 4, like x is
4
from
to 8 or something. Yeah.
yeah. So but then when we calculate x is less than equal to 4, and there will be something mentioned as x is greater than 4, x is less than 4 also. But in x is like in the question I can show you what I mean to say, because there was one question I will tell you of the
Okay.
same thing. Yeah,
Okay, just a minute. Let me explain this first.
sure.
Okay, see, whenever you say probability x is equal to 4, which is equal to probability x less or equal to 4, why are you going with this? Because I'm considering, your CDF, fine? So,
Ma'am, sorry to
CDF is
interrupt.
what?
May I ask a doubt?
Yeah.
So actually, this PDF and PMF, it gives the probability of that particular random variable taking so and so value, and what is the probability, right? Now, this previous week we started this inequality loss, that is also giving that in that range what could be the upper bound or lower bound, right?
Yes.
And here, what is that? I mean, it is also taking to the same thing, right? Like
Yeah.
in that range, what is the probability of that random variable or continuous variable taking the value, right?
Yeah.
I mean, what is the difference? Like what I'm trying to understand is that PDF, PMF, and this inequality law, we already know. This is also taking to the same thing, right?
Yeah.
So when we know the law of inequality, then why? I mean, just trying to understand
Yes,
what
yes.
is the use of this CDF then? How
Yeah.
they are different?
Yeah, I will tell you. Just a minute. Okay, let me finish this, then I will come to your point. Okay. Probability x less or equal to 4, that means you are using your CDF things, because CDF is what? It is probability of x taking less or equal to values, right? So imagine your real line. So once you are calculating probability x less or equal to 4, that means you are considering all this part, right? Minus, you are subtracting x less than 4, that means you are excluding this 4 and subtracting whole part. So what remained is nothing but the x is equal to 4. Is it okay? Like, was there?
Yeah, it's understood.
Okay. So, yeah. So, yeah, whenever there is an experiment, this is the answer to that thing someone asked, if we have studied inequalities. Okay. Inequalities, like in inequalities, what we have done, we used to know that some x is some random variable, and we were calculating what is the upper bound or lower bound that x is taking these that values, right? And we, using inequality, we used to approximate upper bound and lower bound, right? Upper bound or lower
Right,
bound,
right.
but not exactly what the probability is. Fine.
Yeah, I agree.
Using inequality, you can't say, okay, this is the probability. Okay. But with CDF, let's come to CDF. So when CDF is there, what CDF says to you? It's by definition, it is nothing but the probability that x is taking value which is less or equal to x, right? So this is what exact calculation is. But like, you can't come to CDF if you don't know the distribution of random variable x. The thing is, first you need to have x, a random variable. Okay, if it follows some defined distribution or well-known distribution, like say uniform, normal, or geometric distribution, at that time you know it's PMF or PDF. I'm using two words, PMF or PDF. Why? Because if your x is a discrete random variable, at that time you have probability mass function, or let's say, let's talk about PDF only, probability distribution function. You know PDF or CDF, and then you alter with these two things. Now, once you have CDF, at that time, what it gives you? It gives you cumulative probability, not a particular probability. Fine. You may have seen this type of, let's say, I think you may have seen this type of graph, or have you seen this? Like, it is nothing but the CDF for normal distribution. And one thing in CDF that is to be noticed is that this value will approach to 1 at max. Okay, then after that it will not increase. Why? Because once your event has taken all the possible values that your random variable can take, at that time your CDF will saturate at 1 and will not increase further. Fine. So CDF will give some continuous graph using which you find PDF. PDF, what is PDF? So probability density function. Why it is needed? At that time, recently I just wrote that probability that your X is taking, your random variable is taking values lying between A and B. Using CDF, that means this graph, which is CDF of some random variable X, at that time, can you just tell me, like, what's the, let's say some point A is here, and I'm asking, like, what is the probability that your random variable will take value A? So at that time, you know one rule that X is a continuous random variable. So probability that your random variable is taking value A is 0. But if someone wants to know what is the probability that random variable X is taking value lying around A, not a, like, it's a small interval, at that time you will need probability density function. Why it is so? Probability density function will give you the probability that your X is lying between, let's say, neighborhood of A. That means I will write A minus epsilon, A plus epsilon. Is that fine for you if I write neighborhood as this? You might have studied these things in mathematics, right?
Right.
Yeah. So once, if someone knows the CDF, that means distribution function of this random variable X, but from this distribution you can't you can't say that what's the density, like what's the probability that your random variable is taking values lying between these two, because this X have several intervals, right? But the distribution of random variable, that means your random variable will not take values lying between, let's say, let's come to number only, that will be fine, A or let's say B. Okay, it will not be the same probability that your random variable X will take values lying around in the neighborhood of B is equal to the probability random variable is taking values between this A minus epsilon to A plus epsilon. That means in neighborhood of A and neighborhood of B, the distribution of random variable will not be same. Distribution means, okay, it might be confusing. See, so I'm just relating it with a discrete random variable, okay, but just don't mix them. I'm just relating it. It's analogy, but not same, okay. Let's say you have thrown a coin 1000 times, okay. So 1000 times, and so it's obvious that if two persons, let's say person A and person B, are doing the same experiment, P1 and P2, okay, then like coin is tossed 1000 times with by P1 and by P2 also, okay. But it's obvious that if P1 tosses the coin, the number of heads and number of tails will not be the same, like what the P2 get, right? Is it understood? It may be possible that P2 will get 600 times head and 400 times tails. Is it so? Hello? Are you getting this point?
Yeah, yes.
Yes,
Yeah.
ma'am.
And with person 2, it may be possible that head is coming 300 times and tail is coming some rest of the 700 times, right? That's what distribution of x. In this case, your x will be what? The 0 and 1 you tell, right? Whenever we toss a coin, at that time we generally define a random variable x, which is 0 when it is a head and 1 when it is a tail, right? So if you draw the graph for this P1 and P2, then graph will not be same, right? The occurrence of 0, that means occurrence of head for both of them are different. But this was a simple example, and here the outcome means range of this random variable is limited, only 2 points. So you can just graph it and observe what is the probability, what is the probability only, or what is the distribution. But the same thing is not possible with continuous random variable. In that, first thing we noted that the probability at any point is 0 if your x is a continuous random variable. Then if you want to calculate probability at a particular point, it is 0. Then but you want to know the distribution, right? That's what your purpose is. If you do some experiment, then let's say you are investing in stock markets, then you want to know in which time interval there is a high chance that the value of your stock price will increase or decrease, right? So you are interested in time interval in that particular case. But for that, you need to know that what is that particular time, where the density, where are the maximum chances that prices will increase, right? For that, you have to check interval by interval. So let's say this A is one of the interval, that is interval nothing but the neighborhood of A. B is one of the interval, neighborhood of B. Now you want to compare whether this x, a random variable, is taking maximum values between this interval or this interval. Okay, are you getting my point?
Yeah, yes, yes.
Okay. So if you go with the CDF, at that time, person will
Could
say,
you just repeat the last this thing?
sorry,
So that in between this, just could you repeat the last one?
what last one? This P1, P2 things?
Yeah, just before.
Okay. Yeah, so this was one of the experiment that two person has tossed coin 1,000 times separately. Okay. So if the experiment is tossing a coin, then at that time we generally define random variable x as a 0 when it is taking head and 1 when it is tail. So if you want to, then obviously if two person are tossing coin independently, then the number of heads and tail will not be same for both of them, right?
Yes, yes.
So if this person will graph the particular thing, that number of zeros and number of 1 it has, so it is 600 and 400, it is 300 and 400. So from this, I want to just give you the idea that what are we interested in this continuous. If the experiment is discrete, at that time we can say that, okay, what is the occurrence of 0 and what is the occurrence of 1? We can use these words when we have a talk about discrete random variable. Okay, but when we are talking about the continuous random variable, at that time we can't say what is the probability that the value occurrence of A or occurrence of B. Fine. So we have to move to interval kind of things. So so someone will say me, okay, then if my B is here and A is here, just a minute, okay, let me finish this. If my A is here and B is here, and you want to calculate occurrence of the particular thing, that means random variable taking values between in the neighborhood of A, then you will go with this formula. Okay, then this is this one is PDF, this is not CDF, right? If someone wants to calculate what are the values x is what is the probability that the random variable is taking values in the neighborhood of A? If you just calculate directly f of A and directly calculate f of B, then in CDF, one thing I can guarantee always, that whenever the point is, if you are calculating CDF at two things, then obviously the right side number will have higher probability than the left one. Why it is so? Because f of x is an increasing function. It's adding these probabilities also. So this will not give you the intuition for like number of occurrences of a random variable taking values between this interval about A or interval about B. For this purpose, you have to move forward and you have to go to PDF, probability density function, which will tell you the probability for a particular interval. Because in CDF, if the value of f of x is high, doesn't mean the density is high or the occurrence of random variable taking that particular value is high. Okay, if f of x is high, doesn't mean the random variable is taking more values around these points. No, it's not like that. It may be possible that this random variable is taking more values in the neighborhood of B, or it may be possible that it's taking more values in the neighborhood of A. Are you getting my point? What I want to say?
Last one is a little confusing. I didn't
Yeah.
understand taking more values in the neighborhood of.
So I just give you the example of that stock pricing.
So
Okay.
the steep would be more.
Yeah.
Steep would be more. I think so.
Sorry.
The steep would be more. I mean,
Steep would be more. But with this CDF graph, you can't predict anything for the density of the things or occurrence of random variable. Occurrence of an event, I should say, because what random variable is, this x is a random variable, right? What does it include? What does it mean by a random variable? It just connect our event with numbers, right? Do you remember this?
yes.
What was the purpose of random variable? To connect our event with a numbers, right? So this random variable will take some numbers, and then we will have some distribution and all this thing, and then we analyze the particular thing, right? So let's say someone is investing in stocks. At that time, he or she might be interested to know in what particular time the stock prices will increase or decrease, although it's not fixed. So we can change the example by let's say one of the person, he is running a, let's say he is selling TVs and all this thing. At that time, he will have some particular time at which his sell will be higher, right, or lower. In festival season, the sales will be higher. But if you draw this cumulative distribution for the particular shopkeeper, at that time the CDF will be increasing only, but it may be possible that on 1st January only you have higher sale than the last, like in the November month, right? So to know that particular distribution, that at particular interval, what's your probability of your random variable or number of TVs sold, you have to go with the PDF, which will tell you the probability of random variable taking values between A and B. For that, we need PDF. CDF is for what? If you want to know like cumulative kind of things, at that time CDF is needed. But some distributions are like that, or sometimes we define a random variable, which are for which to define CDF and PDF it's more tricky task. At that time, we go with the inequalities, which will not give you the exact probability, but it will give you the intuition that okay, your probability for your random variable x taking this value will not go higher than this value. So this will also help in some sense. Okay. Did you got the difference
Yeah,
or still there is?
I got it.
Okay.
So whatever we discussed now, one more doubt, two more doubt here.
Yeah.
This PDF, are we saying it is not at a specific value, but the like some minor? I mean, it is a small area around the value like that. We are calculating PDF, not
Yes.
at.
Not
Okay.
we can't find at a particular point. Why it is so okay? So it's just if you read some book, no, and that things you will come to know that. See, whenever it's a discrete random variable, discrete means it will take finite values, right? That means your random variable has finite range, right? Discrete random variable will always has a finite range. If there is a finite range, it's very easy to calculate one by one what is the probability that particular thing is occurring, right? But whenever it's a continuous random variable, at that time your random variable will be your range for the random variable is uncountable.
Okay, got it. So it is not finite. So that is the reason you have to go for the
Interval.
full delta area around the particular value, like you told epsilon.
Yes.
And what is the relevance of event to the continuous number? Because event are always discrete, right? I mean, either event happened or not happened, right? Why you are talking about continuous event? Like you told, na?
Continuous event means
So you told, na, like
no. I just told you the random variable. What
the,
is random variable? Random variable is nothing but to connect the events with a number. If you remember your statistics 1 lectures, and at that some point we have defined that a random variable is a function which is defined from the event to a number. For example, if you are tossing a coin, at that time your events are head and tail, but we always deal random variable in terms of 0 and 1. How it is possible? Because we defined x as a function which is taking value 0 if it is a head and 1 if it is taking a tail. So what we did here, we what we say, connected our event with numbers, right? Is it okay?
yes, understood.
But see, this was the event which was taking finite value. So here it worked. But some events are like they will take uncountable values. Let's say the meteoroid weight sir has discussed in the class, right? Or if you want to calculate the height of the persons on the earth, at that time this omega, this sample space will not be this much small, right? This will vary so large, like from let's say 1 feet to, if I say ideal, 1 feet to 7 feet, but the numbers will be uncountable in between them, right? So this kind of things, when you calculate, when this kind of data is there, at that time your random variable will be continuous random variable. Okay, fine. PDF, first let me know, just clear me, is it clear? Should we move further or?
It is clear. Is
I'm
there
clear.
an example you can give? Even a small example would be okay.
Sorry, please repeat.
Small example, I mean working example kinds.
For
For
what?
the continuous one.
Continuous random variable.
Yes, yes.
Okay.
Small, even if it's a small one also, taking few values.
Few values, see, whenever it's a continuous random number, the values will be uncountable only.
Uncountable.
But let's say, okay. Any example, let's say you are calculating your data set is height of the persons on the earth. Okay. So if it is a
Hmm.
height of persons, okay, fine. On the earth, I'm telling, okay. So it's not
Okay.
possible to calculate everyone's height, right?
Hmm.
So what will be your range set, like what your x can take? Let's say, just it's just an assumption. I don't know what's like. Let's say 0 point, not 0 point, minimum 5 or what? In terms of centimeter, if I want to say, then let's say from 20 centimeter. Okay, I'm just assuming this is a hypothesis value. It may be possible that someone like persons or newborns are maximum than 20 centimeter. Okay, so let's say 20 centimeter to or 200 centimeter. Okay, but there will be some persons whose height will be okay 151.1 centimeter, 151.5 centimeter. All possibilities are there, and if you come with the precision, more precise value, then it may be possible that 151.51 is there, and so on. So how many values are there between this 20 to 200 is just uncountable, right?
Correct.
Yeah. So but whenever you will collect the data, at that time this data will follow some distribution. Just let me take it as a 50, and let's say you have collected data in some particular region where the maximum people are having height more than 150 on 140 only. Okay, and obviously the height, the person who is having height 200, that means more than 6 na. Yeah. So person having 200 height is actually rare, right? And person having height 50 is also rare. So at that time, uh, see, if you plot all these things, all this data into a point, that means how will you plot first? You will say, okay, this is my x values. Okay. These are my x values. Person taking height 50, 100, let's say, okay, 50, 100. So you will count number of persons, right? Number of persons whose height is 50. Let's say some X number of peoples are having this height. This is again a hypothetical. Okay, I'm just taking this data randomly. So it may be possible that person having 100 are more than person having height 50. And obviously in this region also there will be some people whose height will be okay. Some will be high, low, high, low. It will be like that. And at some point you will get okay, this particular, let's say 150 height, like person having 150 is more, 250 is again very low, sorry, 200 will be again low, and this kind of graph will be there at that time. Yeah, from this example it will be easy to explain, see that density function. Okay, so this kind of graph you may come up with. Okay, so if someone wants to know that what is the probability that person in that particular region having height lying between, let's say, 170 to 200. Okay, so what will you do? If you have collected, if you are able to collect the data, which is not possible if I am saying height of the person on the earth, obviously not possible, because you can't even measure the height of person in one city also. Uh, like it is possible, but it's very tedious task, right? So you will just consider one small region or your neighborhood people's height, and you will collect some data and you will draw some data. And for that particular region, if someone wants what is the probability that person's height is lying between 170 to 200, then what will you do? You can calculate this probability very easily, right? Number of peoples, you know how many peoples you have, like for how many peoples you have measured the height, and how many people are lying between this data, and you will easily predict, you easily say this is the probability that person's height is lying between 170 to 200. But with the large data, how it is possible to come up with it? So with this distribution, if this distribution is some standard distribution, let's say some normal or geometric or something, at that time, some scientists have already defined the functions for that PDF and CDF. So if you want to calculate this probability, you will go with the PDF of that particular function or PDF for that particular random variable, whatever it's following, and you will just say, you will just calculate the probability. Fine. Okay. And for the same thing, if you go with the CDF, then what is f of 200? For the same thing, okay, you have measured the height and all this thing you have done, and now someone is asking what is f of 200, that means CDF. Then it is definitely, yeah, what is?
1, man.
Yeah, definitely it is 1. But it's not giving any information regarding this thing about okay, person's height lying between 170
How
to.
it is 1?
Huh?
How it is 1? F of 200 is 1?
Yeah. See, CDF is what? Cumulative distribution function. That means you will add all the probabilities that is less or equal to 200.
Correct.
And we have, and our range set was 50 to 200 only. Okay.
So now this one, just the CDF and PDF, the analogy what you gave, the stock analysis, can you say that PDF will give in that range, what is the peak? Like what is the maximum price the share can reach to? And CDF will give the, what is the bound? I mean, where it will reach to saturation, and beyond that it will not increase the price. I'm just trying to understand with the analogy, not.
See, it will not give you the highest value. You told highest value, right? For PDF. It's not giving highest value, it's giving highest occurrence. There is a difference between highest value and highest occurrence. Occurrence, let me give you one example. Again, with the discrete one, it will be easy to like understand. Then we can relate it with the continuous. Let's say someone is throwing a die, or let's say not throwing a die, it's like we are using it again and again. Let's say there is some person who is a magic man. Okay, so he's asking people to take any number lying between 1 to 100. Okay, so this is a, okay, just let me just tell me whether it will be a discrete or continuous at that time. There is a person, discrete, right? So it will be easy to calculate that how many people chose 1, 2, 3, and so on, right? So let's say some 1 to 100 will be more. Let's take it 1 to 10 only. Okay. And there are some lakhs of people there, and every person has to choose a number lying between 1 to 10. Okay. Then it's obvious that that some number will be occurred so many times, right? Are you getting my point? There are lakhs of 1 lakh people. They have to choose number between 1 to 10. At that time, and you are a statistician and you are just going there to you want to analyze something, what number is the, like, people will choose more between 1 to 10. Okay, so it may be possible that highest occurrence is not for 10, it is for some 6 or 7 or any random number, right? 8, 9 and 10. Okay,
It is
so
like
here,
rating.
it's not rating, I'm just telling, okay, some person is there in front of you, and you are among that lakhs of people, and you have to choose any number lying between 1 to 10. Okay, so it's just an, what we say, voluntary, like whatever you like, you will choose that number, right? So let's say people will choose the number 6 is the highest one. Some hundreds of people only chose the number 1. Some people has chose this number 3 and so on. Then this graph will be like this, right? Some random graph will be there. So here the highest number is 10, but highest occurrence is for 6, right?
Right.
So yeah, come back to the question PDF. So once you go with the PDF, it will give you highest occurrence. Okay, it will give you the highest occurrence if you choose particular interval only, because you have R as your range, right? And you have to look at the data, look at the distribution, and find, okay, which interval will have highest probability or which has the highest density.
Okay, so if I'm just taking same example, let's say for some share price it is 100 to 200. The maximum price is not let's say 150, but it may go to a peak at 150. What it means is that there is a high probability. The maximum probability is at 150, wherein it may go till 200.
No. It's not a maximum probability. It's a probability that the price of that particular stock may have highest value as 150, whose probability might be 0.1. Are you getting my point? But let's say the range, range of that particular stock is lying between 50 and 150, let's say 50 and 200, okay? Okay, you took 150 as a highest, right? So at max, it can go to 150, but whenever you are checking, it's lying between, okay, 70 to 80, 70 to 80, 70 to 80. Then the highest probability is for 70 to 80, that the price is going to 70 to 80 maximum of the times, right?
Right.
So highest probability will be for this, maybe some 0.4, or highest value attained by that particular stock will be 150. That's a different story. For example, this one, highest number is 10, but it may be possible that out of lakhs of people, only some 50 people has selected this number 10. So this 10 is highest number, which is one of the possibility that person would check will select number 10. Okay, but maximum of the peoples have selected number 6. That means highest occurrence is for this number 6. Similarly here.
I think you're saying you most frequently occurring. That's what you mean.
Yeah,
right?
most frequently occurred.
Almost like the mode of the data set.
Yeah. So whenever you go with the PDF, probability distribution function, density function. Okay, just tell me what is what do you mean by density in physics also? In physics or in general term, we use the term density, right?
Density.
Number of objects present per unit volume or something.
Mass
Yeah.
over volume.
Okay, number of objects per volume, or what?
Mass over volume.
Mass over volume. Okay. Yeah, mass over volume. What does it mean? Here, let's say there is a, okay. In this particular case, when we have PDF, it is nothing but the, it is like we can say it's the amount of probability per unit length. Why I am using word length here? Because we are interested in intervals. Why we are interested in intervals? Because our random variable is continuous, which will not allow us to calculate probability for a single digit, for a single, what we say, number, right? That's why we are interested in intervals. So once intervals are there, every interval have length. Okay, just a minute. The person who is not speaking, please keep your mic off. Thank you. So yeah, here in this PDF kind of things, it's the probability per unit length. That means, let's take an example where the probability distribution function is, sorry, density function is given there to you. This is one of the density function given to you. Density means what? You just told me that only. Mass per volume. Here it's a amount per length. Okay. So these are the value of x. Okay. And so on here also. Okay. This is not the limit only. Let's say this is the peak and this value is 0 only. And this one is f of x, PDF. Okay. Now, with this diagram, let's say 1 is here and minus 1 is here. Just tell me by looking the graph only, and here is somewhat, let's say 5, 6, and 7. Like it's an observation. Just try to observe and just tell me if I want to calculate probability that x is lying between -1 to 1 and probability that x is lying between 5 to 7. What can you just observe from this particular graph?
First case is maximum.
First one is a
Maximum.
maximum. Okay, now you are using word maximum. That means
Tends to 1.
Yeah.
It tends to 1.
It tends to 1. Okay. How? See, probability tending to 1 is totally different thing. Yeah. Will you please elaborate what you want to say?
Ma'am, I was just guessing like it is maximum, so it must be approximately equal to 1 or something.
No. See, whenever the probability will be 1, but it will be when you consider the area of the whole graph or PDF. At that time only it will be 1.
This should be like probability till 1 minus probability till minus probability till -1. So probably from -1 belongs smaller than equal to x, smaller than 1.
In this case, it would be 0.5, I believe, no?
Yeah. See, I just want which one is the larger here? So obviously this one is larger, right? But just notice one thing: the length of interval for both of them is 2, isn't it? For both of them, length of interval is 2.
Yes, ma'am.
But the probability is 2, right? But probability for this one is higher than x lying between 5 to 7. So x is a random variable whose highest value will always be tending towards infinity. That means the highest value will not have probability higher than this value, right? This example was to just clarify the probability that probability of particular interval is higher even though it's not the maximum value, right? This -1 to 1 interval. Okay, just tell me one thing: what this -1, 1, 5, 6, 7, what are these values? Like, what are these indicating? Right?
These are random. I mean, the continuous variable in this case. What is the value it is taking at?
Yeah. So these are the values taken by this x, right? So once a person says that probability that x is lying between -1 to 1 is greater than probability that x is lying between 5 to 7. If someone wants to explain this in language, then what should they say? Any guesses? That means this interval, the occurrence for this random variable is more dense in this area compared to this area, isn't it? Like that means the density of x taking values between -1 to 1 is more in this -1 to 1 interval as compared to density in this 5 to 7 region. Are you getting it?
Yes.
Yeah, got it.
But just tell me one thing. If I know the CDF for this particular distribution, then why I am going to PDF? Now can you explain me, like we had so much discussion over PDF and CDF with various examples. So now my question is, can you explain me, even though you had CDF, even though you had inequalities, but still you are going to learn PDF? Why?
We can't, most occurring one we can't find.
Yeah, most occurring, and maybe the if you want to take decision over a particular thing, then this will be more helpful than those. See, CDF have its own uses. Inequalities have its own uses. Now the new term PDF is there. So we are learning its uses, how to use it. And actually the thing is, to calculate PDF is much more easier than to go with the CDF, to go with the calculation with CDF and all. So for example, if you know CDF, then you will be easily, it is very easy to calculate these values, right? You will just subtract f of 1 minus f of minus 1, isn't it? But let's say, okay.
Ma'am,
Yeah.
I have one doubt.
Mhm.
You explained that this interval -1 to 1
Mhm.
is having more density.
Yes,
I'm confused. It is having more density or it is having more occurrences?
occurrences.
Occurrences, because the area
Okay.
is different.
Yeah, area is different. And why I can say more density, more occurrence, because the length of interval is same for both of these intervals.
But height it is gaining is different.
See, it's occurrence only.
Okay, yes, occurrences.
Yeah, it's it's occurrence only.
So that could be answer of your next question, that in case of this PDF, we are comparing per unit length.
Yes, we are comparing per unit. Yeah, fine. So, okay, anyone has doubt in this particular example or anything till now what we have discussed? Okay. So one thing is there to note, that this PDF will never take the values less than 0. That means it will be always positive. F of x will always be greater or equal to 0. It will never be less than 0, like CDF. In CDF, we have talked about, okay, x is going to negative infinity. At that time, f of x will go to 0. That means the CDF can be discussed at negative integers also, but PDF not. Okay, so yeah, the range is half, you can say 0 to infinity. Okay, then one more question I want to just tell me whether you just try it. Okay, as you know that the range of f of x is lying between 0 to 1, right? It will never go range. I'm talking about range only. Okay, it will never go up by 0. Sorry, 1. Can PDF be more than 1?
Yes.
Okay. Yes, then how? Example or why? Whatever you can explain.
I think it will not go beyond 1. My understanding is, again, with the help of this coordinate geometry, this entire area under the PDF, CDF is 1, and PDF is a fraction of that if we break that into units.
Sorry, will you please repeat
So the total area, let's say for if we plot this in some particular coordinate geometry, then the entire area under the CDF is 1.
Yeah.
And PDF is nothing but if we break that into some unit portion, that gives the PDF. So it should be less than 1.
It should be less than 1. Okay. Anyone else?
Yes, ma'am. PDF can be greater than 1. If we reduce that length, that will increase. That,
Yeah. Example or explain it. See, yes, PDF is what? Probability density function. And if we go with the CDF, that is cumulative distribution function for the random variable x. Here, in CDF, we calculate probability x less or equal to, like, probability that small x, like all the values x, lying between, like between negative infinity to x. So at that time, at the point, let's say x is a random variable which has some range. So once that highest number is like occurred, after that you calculate, let's say this small x naught is the highest value that your random variable can attain. At that time, probability x less or equal to x naught means all the number sum of all the numbers, sum of all the probabilities that random variable x can take. And once it has attained the highest number at that point, that means it has occurred all the number, because we are considering x less or equal to x naught. So all the what we say possibilities are considered. That means after that this sum will be 1, because for any experiment the probability of all the possible outcomes is 1, right? Sum of all the possible outcomes, sum of probabilities of all possible outcomes is 1, right? Understood? But here it's a probability density function. It's not probability of anything. It's kind of giving density for particular thing, for distribution of random variable x. So as someone has said, it's a density. Density is what? In physics we used to say it mass per volume. So if your volume is okay, and here in this particular case it's nothing but amount of probability divided by your length, per unit length. So once you reduce your length, at that time your density will increase. Why? Let's say, okay, I will give you first.
Inversely proportional.
Yeah, inversely proportionality. So actually I don't want to go to physics, so that's it. And I don't know like maths and all. Like maths 1 course is like, where do you have reached there? Okay. So if I say you like just construct a PDF for this particular example if you can. If your x is taking some values, let's say it's taking values 0 to 2, let's say 1/3, or 3x it's taking 3x, and your range for the values taking is 0 to 1 by 3 and 0 otherwise. Then just first check whether it has like correct distribution or not. Let me just change it a little bit. It's x lying between 0 to 3 and CDF. It's a CDF. Then can you just calculate PDF and whether it's correct or not? And what is the how will you draw the PDF for the same thing? Like we have some in week 4, we have some graphical representation also. So I'm just going with that. If your CDF for the particular random variable x is given like this, then how will you proceed it? Sorry, it should not be 1, otherwise it should be 1 more than, like whenever your x is greater than 1 by 3 and 0 when x is less than 0. Yeah.
I think this one you can plot in graph, right? So it will be 0 to it will be a triangle kind of shape in the near to x. I mean,
see, it's a CDF.
Yeah.
Can it have triangle kind of things?
Oh no, sorry.
Because whenever you want to draw a triangle, you have to go up and then come back to down. It's not possible, right, for CDF?
Yes, definition says it is a non-negative.
Increasing function.
Increasing function.
So just try it. It's CDF and PDF, and we just want to check. We are looking for the answer for this question. Can PDF be greater than 1 or not? But before moving further, just once check whether when you comes to its PDF, whether that's a valid PDF or not. Do you know how to calculate, how to check that?
This one, if we disintegrate, I mean, if we do a derivative of 3x in this range, I mean, then we get the value, right? The PDF.
Yeah. Yes, someone is speaking here.
Yes. How to calculate valid PDF?
Yeah. What is valid PDF then? If you its integration should be 1, right? Valid PDF is what? The area under the curve should be equal to 1.
1, correct. Correct.
Yeah.
So, ma'am, by differentiating, we get.
You get?
Ma'am, if we differentiate 3x, then we get 3. So it's not a valid PDF.
It will get 3, and it's not a valid PM. Okay. Why? It's 3, right? But just consider this one also. And x is a continuous random variable.
PDF is 0.5. This
PDF is
0.5.
0.5. How?
I just did a derivative of 3x in that range.
You just did a derivative in this range. Like how?
No, like it will be x square by 2, right? 3 by 2 into x square, and then no.
You are doing derivative or integration?
Oh, this is CDF is given.
See, derivative of CDF will give you PDF. Okay. So the derivative for this particular CDF is f of x is equal to 3 whenever your x is lying between 0 to 1 by 3 and 0 otherwise, right?
Right.
Now just tell me whether it's a valid PDF or not. What's valid PDF?
Integration should
A
be 1.
under the curve should be equal to 1.
3 into 1 by 3, 1.
Okay. Yeah.
So,
So,
Yeah, ma'am,
so
now
this
that
is a valid
integral
is
from,
valid.
just a minute, yeah. Go one by one. Integral 0 to infinity, because PDF do not take values lower than 0. 0 to infinity, it should be equal to 1. So let's just take integral 0 to infinity, this particular f of x. So here the integral is 0 for all the range, but when you integrate 0 to 1 by 3, it's 3 dx, right? And once you integrate it, it's nothing but the 3 into 3x lying between 0 to 1 by 3, which is
3 into 1 by 3.
1 only, right? 3 into 1 by 3 minus 0,
Zero.
right? So
Yes,
it's
ma'am.
a valid PMF,
Yeah,
valid PDF.
yes, ma'am.
So okay, it's valid. But just check one thing. Does it give an answer to our question? Can PDF be greater than 1?
Yes, ma'am.
Yes, it can be. Okay. Yes. Did you understand why it happened? Because once you draw the graph for this particular PDF, how will it look like? It will be something like this. Do you guys have pen and paper with you?
Yes, ma'am.
Okay, how is the graph looking like if you have drawn? I'm just denoting zero sum above so that we can. Okay, from 0, let's say 0 is somewhere here. I have denoted here. Let's say -1, +1. Here also like that. 0 and +1. Okay. We need here 3 only, right? Yeah. Done? Yeah. How is it looking like? 1 by 3 will be somewhere here. Let's say 1 by 3 here. Okay. For this particular 1 by 3 only. Okay, yeah. Yeah. Your PDF is 0 for all the values, but whenever it goes from 0 to 1 by 3, right? It's 0. Once it attains 0, it will go to 3. Then till 1 by 3, it will stay at 3 and then again go back to 0 and so on. Did you get the graph like this for this PDF? See, your PDF is giving 0 for all the values lying outside 0 to 1 by 3. So I just plotted 0 here so that we can observe it clearly. So this is your x values, this is your f of x. Whenever x is lying between 0 to 1 by 3, your graph will stay at 3, right? Rest of the time it will be here only. And the integration under this curve is 1, as we have checked here, right? Any doubt?
I have a doubt in one activity question. Can I share that?
Yeah, sure. Just a minute.
Oh.
This one is fine.
Okay.
Yeah, okay.
So, if you guys have any doubt from the week 4, that you can ask here, and otherwise we will start with this activity question.
Can I
Yes,
ask you the doubt, or can I share my screen?
No, you just tell me. I will share.
Okay, activity question 4.2, activity AQ 4.2, question number.
Okay. Just a minute. Just a minute. Hold. Yeah. Anyone else has any doubt from doubt till this?
Just
Yeah.
asking this week 4, was there any other thing? I mean, did we miss anything that you wanted to cover? So, or this CDF and PDF concept?
The CDF PDF concept, this graphical concept is there, and some like common distributions we have there, for which we have like learned PDF and CDF for them. Do you want me to cover that? Then I will start with that. Like some
Yes, ma'am.
continuous random variable are like uniform random variables are there.
Yes, ma'am. PDF and CDF for those. This.
You want me to explain that?
Please.
Okay. Okay, then for activity question, I will say in doubt session we will have activity and practice set questions. Is it fine?
Okay, only one thing I wanted to ask you. I have done other questions. Only.
Okay, what's the question there?
AQ activity. Can I share my screen, or should I tell you?
Just a minute.
Activity 4.2, question 10.
Just a minute. Hold on. Yeah, activity 4.2.
Yeah, question 10.
Yeah, this one, probability x less or equal to 1.5.
Yes.
Okay, where is the like main question there?
Yeah, it is. Yeah,
this one, right? Consider the following CDF of a random variable x and answer. Okay. So this is CDF of some random variable x. Okay, from this graph, anyone can say which kind of random variable it is? X.
Is it discrete?
Yeah, discrete.
Discrete, right? Okay, and one more thing I missed, that is there are some graphs, some random variables which are neither discrete nor continuous. I will take that example. Yeah. So for this particular question, he has to calculate probability x less or equal to 1.5. Okay. Anyone want to help here?
0.2.
1.5, right? Probability x lying between x is less or equal to 1.5. So you have to just add all these things. You have to add it, or just directly you can say it's a CDF. It's 0.6 only.
0.6.
Okay, understood.
Okay.
Directly, that's why I was asking whether we need to.
No. It's what CDF is. See, you for till -1 you got 0 because there was nothing, no values that is occurred, that is taken by x for that particular. But when your range was -1 to 1, at that point x may have taken some particular value and the probability increased by 0.2. Then at 1 to 2 it became 1.6, sorry 0.6. But can just anyone tell me what is the probability for this particular example? Probability at x is equal to 1. That is also one concept in week 4. Probability at x is equal to 1. 1.5 x. Yeah.
0.4.
Yeah, 0.4. Why it is?
This will jump from 1. 1 is not included.
Yeah.
And the height is gained at 0.6. This jump will be
Yeah.
the probability.
Yeah, my probability at x is equal to 0 will be 0, correct? No? Because
Probability at x is equal to 0 is
0.
0 because there is no jump. Yeah.
But when we calculate for x is equal to 1, so I understand that it is 0.4 is coming. But if we calculate with the example, the formula, like if you want to, like if you go up, na ma'am, just one question, the same like there. But because this is understood, just
Okay.
one up, the same question, one up, the question number I will tell. This is question number.
This one.
Question number 3. P at x is equal to 4.
Yeah.
Number 3.
Yeah.
Yeah. So here, if we calculate, na madam, for x is equal to 4, then we will write the formula x is less than equal to 3 minus x is less than 3. 4. Sorry.
4 less or equal to 4 minus
Yeah, yeah.
probability x. That we discussed in session also, no?
Yeah. But when we see, when we put the x is less than equal to 4, then it will be 0.88 because here it is x is greater than equal to 4. But how the calculation they are doing 0.88 minus 0.68.
0.68. Yeah.
So,
Correct.
but when we see in the 0.88 is x is greater than equal to 4, not x is less than equal to 4.
Okay. From this,
This
okay.
yeah, just
From this function, just tell me if I am like, you just forget everything and just look at this function only. I'm asking you what is the like CDF at CDF at 4. CDF at 4 means probability x less or equal to 4, right?
Yes.
Probability x less or equal to 4. And just focus on the question. It's not a continuous random variable, it's a discrete random variable.
Yes.
Okay, and I just discussed in session also.
Yeah.
Whenever it's a discrete random variable, you have to calculate probability at a single point also.
Yes.
But when it's a continuous random variable and they are asking about probability at x is equal to 4, directly say it's a 0. But it's a discrete random variable. And now from this function, I am asking you what is CDF at a point 4, that is f of 4. What will be your answer?
0.
Huh? No, f of 4.
F of 4 is 0.88.
0.88.
Yeah.
Why it is so? Probability x less or equal to 4. That is 0.88.
Okay.
Now I am asking what is probability x strictly less than 4. Then
0.68.
So yeah, so 0.88 minus 0.68, isn't it correct?
Yeah, I understand. But x is less than 4 may we are putting 0.68, but 0.88 as per this graph, as per this equation there, it is x is greater than equal to 4, correct? 0.88.
X
And
is?
less, x is greater than equal to 4 and less than 8. But
Okay.
that,
Okay, just let me just present. Okay, you continue, yeah?
Yeah. So x is greater than equal to 4. Probability is 0.88. That is understood. But we are putting 0.88 as x is less than equal to 4 also. Is x is less than equal to 4 also, we are putting 0.88. But in this equation, 0.88, if 4 is less than equal to x, so it means x is greater than equal to 4. If we consider from x point of view. Or is there
Okay.
some misunderstanding?
There are some values. Okay, I'm just explaining it. There are some values above it. So it was 0.68 for x lying between what? Less than 0. Less than 4 only, right?
Yeah. 1. Yeah. 1.
Okay.
1 less than equal to x. Yeah, here 1.
Okay,
Then
less or
than
equal to x less than 4. Okay.
And
And here it was 0.88 from 4 to
4 less than equal to x less great. Yeah.
Yeah, and some rest of the points are here.
Yeah.
If you graph it, okay. So if I want to graph it, just these points only. Okay. Here, this 0.88 is the value whenever x is taking value between 4 and 8, right?
Yes.
Let's
What is
say it's just a notation kind of things.
4 is included, ma'am?
Yeah, 4 is included. So whenever we are interested in probability x less or equal to 4,
Yeah.
at that time we will look at which value, 0.688 or 0.88.
Yeah, that's what.
That is clear to you.
0.68.
Sorry.
Ma'am, equal to 4, 0.88.
0.88. Why it is so?
But actually, yeah, I understand.
Yeah,
But
that's understood. But I just want to want you to convert it in language.
okay.
Why whenever you are whenever you are including 4, at that time you are saying probability x less or equal to is 0.88, right? But when you are x less than 4, it's 0.68, right? But
Right.
the question you have is here it's written as x greater or equal to 4.
Yes, that was
Right?
my doubt.
That is one of the question. Okay, just a minute. 0.68 will, let's say it's somewhere here and 0.88 is here. Okay, I'm just saying it. Okay, and somewhere here it will be 4 and 8 here and 1. Fine. So 1 to 4 your graph is like having like this, right? But 4 is not included, right?
Excellent.
But here when it's starting with the 4 going to 8, it's
Included.
0.8. It's included. So whenever you are calculating x less or equal to 4, at that time you will find CDF from this point to all the possible points in the left, right?
Yes.
Whenever you are calculating probability x less or equal to 4, you are including 4 at that point of time. You don't know what are the values after that. You don't have to do with that, right? You don't have to do anything with that. You are just interested, I want to calculate probability x less than 4, and also it should include 4 also, right?
Right.
But x less than 4, then it's clear, that's not a problem. The thing is your function is taking 0.88 after 4 also, that's a problem for you, right? But why, what's the problem there? If your function is taking 0.88 at a 0.5 also, at a 0.8 also, that's not our issue, right?
Yes.
We are just interested in less or equal to 4. So it is possible that your function is taking 0.88 after 4 and so on till so on. Let's say if there is an example of CDF, let's say this is some of the CDF. Okay, fine. This x will go to till infinity, right?
Right.
Okay. It may be possible that your random variable is attaining only 150. After that, your random variable x is not taking any value. That means your range for x is, let's say, range means it will take only 0 to 150 values only, right? But if someone will ask me what is the CDF at 160, at that time, what will you say? Will you say x is not taking that 160, why should I consider it? No, right?
No.
Because your f of x, your definition for CDF is probability that x is taking all the values which is less or equal to 160. I don't care if my function, if my random variable is not even taking 160 at once also, right? It may be possible that your highest value is 150 only. After that also CDF will be 1. Why? Because of the definition.
Yes.
Are you getting what I want to explain you?
Yes.
And here x less or equal to 4. When it is equal to 4, it's getting 0.88. We are not interested what it will take after the 4, right?
Yeah.
So it's not a look out what it's going to take, what are the values it is going to take after 4. We are just interested till 4 what it is taking, 4 included, right?
Yeah, right.
Okay.
If
Yeah.
we ask for at 5, then it will be 0. X is equal to 5, then it will be 0 in this
Definitely
graph.
0. Yeah, probability at x is equal to 5. At that
5,
time, it is 0.
because it is
But
discrete is given. And
even though its discrete is given, its CDF is given, where CDF do not have any jump. So we will just directly claim it's a 0.
okay, but for like I understand from the graph what thanks for, but in
Yeah.
the when we apply for formula we don't have graph, then I think means it was
We
coming
have
to
to
my
go with this.
mind. Yeah, it was coming to my mind that it was
Hmm.
x is greater than equal to 4, but we are putting x is less than equal to 4 also as 0.88 in the
Yes.
yeah.
Okay. If you say like read it as, if I want to ask you, if I am asking you, x is lying between 4 to 8, what are the other representation for the same thing to represent? X belongs to, yeah,
4 to
closed interval 4 to open interval 8, right?
yeah,
That
right,
means 4 included.
include
Here, if I want to represent this thing, then x belongs to closed 1 and open 4, right?
yeah.
It's just a representation. That's why it might be looks like confusing, but it will be helpful if I think it will be helpful if you convert it in this format.
But if in the same representation, if we ask s is less than equal to 4, then what will be the? Then it will be 0.88 only.
Yeah, 0.88 only, because you have to include 4, value of the 4 also.
Yeah, yeah. And in the above 0.68, 4 is not included. Yeah.
Yes.
Okay.
Okay,
Thank you,
got
ma'am.
it. Yeah.
Got it. Thank you.
Okay. So yeah, there was one more thing that we had left. That is, there are some graphs. Like, okay, this is question to all. Did you guys understand this question? Like, this covered one more topic, that if your PDF is looking like this, at that time, the, let's say x is discrete. That's why it will have jump. Okay. X is a discrete random variable whose PDF will look like this. Let's say 1 onwards here, and something here, let's say 0.2, and for rest of the part it is 0. Okay, this kind of CDF is given to you, and at that point, at that time, you are asked to calculate the probability at a point, let's say 2, probability at x is equal to 2. Then what will be your answer?
0.48, ma'am.
Sorry,
0.48.
48.
probability at x is equal to 2.
0.
Why 0? Okay.
Okay, there is no jump from 1 to 2.
But if I ask you the same question, like probability x less or equal to 2, then
0.2.
sorry, it's a 0.68.
0.68.
Okay. Okay, it's a 0.68. Okay. Hey, are you getting what's the difference there? If not, then please ask. Probability that x is less or equal to 2 is CDF at a point 2. Probability at x is equal to 2, it's the probability that random variable is taking value 2. Right?
Ma'am,
And
probability of x is equals to 2 is equals to 0 is what I didn't understand.
sorry?
Ma'am, I didn't understand why is probability at x equal to 2 0.
Why probability at x is equal to 2 is 0? You're asking that. See, your graph is continuous at this point from 1 to 4. At this particular point, your graph is continuous. At that time, if you ask, like, or you can say there is no jump in the graph in the range 1 to 4, and your 2 is lying in this range only, right? So, whenever your graph do not have jump at a particular point, if you are interested to calculate probability at that particular point, it will be 0 always. Okay, but you're calculating probability at a point where your graph has a jump. For example, probability at x is equal to 1. See, here it is a jump, okay?
Now,
Yeah.
can we relate that in this case from 1 to 4, distribution becomes continuous?
Yeah, it's a it's a continuous only from 1 to 4.
So
4
that's why
not included.
at a particular point it will be 0.
Yeah.
Okay, thank you.
Yeah. Okay.
Ma'am?
Yeah.
Hello?
Yes.
Somewhere in midpoint from 1 to 4, the probability is 0. So why we can't a dot for I mean representing the probability value?
Just a minute, okay? It's just by mistake I wrote 2 here. It's not exactly at a midpoint. It will be 3. 2 might be somewhere here, let's say. Okay, it's just you just understand it. Yeah, so what was your question? If it is at middle at 0, I did not get your question. Can you please repeat?
Ma'am, I'm saying ki, from 1 to 4, in between 1 to 4, probability is 0, right?
Yeah.
So instead of a line, can we represent? Can we put a dot for probability? Like for 1, it's 0.2, and for 4, 0.68.
What's that? I do not understand again. But just let me clear one thing. Probability between 1 to 4 is not 0. If you will ask probability at a particular point, which is lying between 1 and 4, at that time you can say yes, its probability is 0. And I am saying 1 and 4 not included because probability at 1 is not 0 here. Why? What's the probability at x is equal to 1 in this particular question?
0.68.
0.68.
No.
Are you sure? Probability at x is equal to 1.
0.48.
Yeah.
0.48.
0.48.
0.48, right?
Yes.
But the same question if changes to f of 1, then
0.2.
0.68.
Okay. 0.2 or 0.68?
0.68.
0.68, right? Why? Because 1 has to be included. Because of the definition of CDF, probability x less or equal to 1. If you say 0.2, it's the probability x less or equal to x, where small x is strictly less than 1. Okay, it will be more mathematical if I want to say that. Okay, let me just write here. If I want to write probability that capital X less or equal to small x is equal to 0.2 for x less or equal to, for x strictly less than 1. So how many of you got this point? Can I write like that? Is this a correct statement? Can I write for this particular question?
Yes. Yes.
Okay, I'm saying it's no. Now, it's not correct. Why it's not correct? Because probability that x is less or equal to small x is 0.2 for all the values that is lying between 0 to
0
1.
and less than 1.
Right? And be careful with this kind of thing. They may ask you in your quizzes this kind of question, like in every option the slide changes will be there with this less or equal to, or this, let's say x less than 1, and you will forget it and lose your marks unnecessarily. Okay, so yeah, if you ask me like probability at any point lying between 4 and 8 at a particular point, like if I ask you what is the probability x less or equal to 5, then probability x less or equal to 5, that means f of 5 I am asking.
.88.
0.88. Okay, no problem. What is the probability at x is equal to 8?
1.
Probability at x is equal to 8.
1 it is.
0.12.
No.
Again, let's take
0.20.
No.
0.20. Okay.
Probability.
0 no, ma'am.
0.12.
0.12.
Yeah, 0.12. Why it is so? Because probability. Where should I write? Okay. Yeah, probability at x is equal to 8. That is nothing but probability x less or equal to 8 minus probability at x less than 8, right? Isn't
Right.
it?
Right.
So what is probability at x less or equal to 8?
1.
Yeah. And what about x less than 8?
Minus 0.88.
1 minus 0.88. So it's a 0.12, right?
Right.
Okay. So getting the difference, or still should I take one more example like this?
Take one more example. I think then this concept will be like pakka.
Pakka. Okay. Yeah, sure. Okay.
And,
just give me a minute.
sure.
Yeah. If you have a CDF like, okay, just check whether it's giving you particular. Okay, I'm slightly changing the question. It's k by 8. First, I should start with the 0. Let's say f of x is taking the value 0 whenever your x is lying between x is less than 4. And it's taking k by 8 whenever your x is lying between 4 to 6. It's taking k by twice k only. Okay, can you just go for it? What's the value of k here? Sorry, it's PDF. Okay, sorry, there is one mistake here. It's 0 only. It will be, yeah, it's my mistake. Sorry. Okay, are you able to calculate what will be the value for k?
Yes, ma'am.
Okay.
It's 8 by 17.
8 by 17. Okay.
It's a half.
Okay. Just a I think it's integration and subtraction only, right? And addition. Why answers are varying too much?
Sorry, ma'am. I think it's 4 by 25. I did.
Okay, sure. Let's calculate it.
Yes, ma'am. 4 by
So yeah,
20.
for integral 0 to infinity, yeah, 4 by 25.
Yes, ma'am.
Okay. Uh, so yeah, to find the value of k, you have to integrate from 0 to infinity f of x dx is equal to 1, right? So it's nothing but, yeah, for rest of the part it's 0, but 4 to 6 and 6 to 9. Okay. 4 to 6, it will be k by 8. K by 8 dx plus 6 to 9, it's twice k dx, which is equal to 1, right? Okay. Then it will be k by 8 minus 4, 6 minus 4, that means 2 plus twice k. 9 minus 6 is 3, which is equal to 1. Is it correct?
Yes, ma'am.
Okay. K by 4 plus 6k is equal to 1. So yeah, what it is? 25k is equal to 4. So yeah, k is equal to 4 by 25. Okay. So yeah, k is equal to 4 by 24, but we was like interested in another thing. Okay, fine. So this is how you calculate values of any k if you are given with the PDF. But we need to, we were like interested in finding probability if CDF is given. Okay, I was telling you one more kind of random variables are there which are kind of neither discrete nor continuous. This is slightly different that we did earlier, but you will find something interesting here. Let's say some CDF is there. Okay, from graph you are picking easily. I am just giving you function. Okay, if function is given to you, let's say f of x, are you able to calculate probabilities from there? Okay, let's say your f of x is 0 whenever your x is less than 0, and it's taking value 0.3 plus 0.3x whenever your value for x is lying between 0 to 5. Okay, and 1 for x greater than 5. And sorry, it's not included here. equal to 5. Okay. From this question, I am just asking you, what is the probability at x is equal to 4? How will you go with that? Probability x is equal to 4. What will be your probability? 0. Fine.
We have to x is equal to 4.
Yeah. And just tell me whether it's what kind of random variable it is. It's a continuous, discrete, what?
This is
continuous till less than 5.
Sorry, your voice was broken.
He's telling continuous till less than 5, which is correct,
Less.
but
Straight line y is equal to mx.
Okay.
This is a random variable.
Yeah, this is a random variable. Yeah. This is definitely a random. This is a CDF. And I just started the session only. I told if there is a CDF, there will be a random variable which is associated with it. So, okay, it's continuous in between 0 to 5, right? Okay. If we change it a little bit, like, let's say, I'm just changing some values only. Now, just find the probability at x is equal to 4. What is it?
So this we have to integrate with respect to x, right? And then x exactly 4.
0?
0 to 5, I think 0 to 5 we have to take the range. Correct, no? Or
is it so?
0.9.
Just take, I will just tell you, just take your time, just don't rush to answer.
We need an
Just take
integration.
a minute.
Okay. We don't
Just
need
take a minute and yeah, you don't need
integration because there is no PDF involved. Just we can. My answer is coming 0.9.
Okay. Okay, I'm just writing all the possible answers coming from you, but I will suggest you just don't rush. Just clear, like stay calm and say what's the CDF is given, and they are asking about probability at x is equal to 4. We have done similar kind of thing, so you can answer it. Just don't rush.
it is 0.9, correct?
Okay. Anyone else? Okay, just tell me what kind of random variable x is. Yeah, you were saying anything?
It is given. It is continuous or not given.
It's nothing is given. Only this CDF is given there. I am asking whether it's a continuous or discrete.
This is discrete.
Okay.
If it is discrete, then it will be 0 probability.
No.
I just give you a hint. You just try it. Just try to graph it, like plot it, how it looks like.
It is a kind of if this is straight line, no? Or it
Yeah.
is kind of y is equal to mx plus c.
Yes. Okay, I'm plotting here. So yeah, x0, 5 and more than 5, right? Okay, I'm just taking 0 here. So just clear vision only. 2, 4 and 6 and so on. Okay, and here yeah, so how it should be? From less than 0, it's taking 0, right? But 0 not included. Okay, from 0 to 5, your intercept is 0.5, and from 5 onwards, let's say 5 is here somewhere, 1 might be here, it's like around here only. Yeah, from 5 onwards, greater than 5, it's taking 1, right? From 0 to 5, it's taking 0.5 plus 0.1x. So just again, yeah, at 0 it is taking 0.5, and further it's connected like that. Now you just tell me it's a continuous or discrete random variable. You told me it's a discrete random variable. If it's a discrete, then just look the graph after 0. After 0, is it a continuous or discrete?
Continuous.
Right? But before 0, it's like from 0 to, if you say check it from -2 to 5, at that point it's not continuous. So this kind of graphs are like neither discrete nor continuous. Okay, mixture, they say it mixture, but okay, leave it terminology. Now the question was, find probability at x is equal to 4. That means at this point, what is the probability at x is equal to 4?
0.
Yeah, it's 0, not 0.9. Fine. You got it. Why it's not 0.9?
Because of continuous.
It's continuous after 0, right? A similar question we were dealing with that 0.68, 0.88 kind of things, right? Now, if someone asks you the probability x less or equal to 4, then capital X less or equal to 4.
0.5.
I just told you, just don't rush. The question is changed, but somewhat similar.
What is the question, ma'am, now?
This is This is CDF.
You are asking what is the value of at
X
0.
less or equal to 4. Probability at x is less or equal to 4.
Again 0.
No, ma'am.
Okay, just note this question so that I can scroll down. This is CDF.
Equal to 4 is 0.9.
Okay, this is CDF. I have plotted the graph from the same CDF, and now we are moving to the questions. So first one was probability x is equal to 4. So we checked the graph is continuous after 0 to infinity. So probability at x is equal to 4 is directly 0. The next question was probability x less or equal to 4. At that time, how will you go? It's nothing but f of 4. So just go to the function. Where is 4 lying? Okay, 4 is lying somewhere here. That means it's following 0.5 plus 0.1x, right? So you have to just put that value 0.5 plus 0.1 into 4, right? Are you getting it?
Yes, ma'am.
In the previous question, there was directly mentioned numbers 0.68 and 0.88. You were using it. Now the function is given to you. You have to put that values. So it's 0.9, right? Okay. Now the question is, what is the probability at x is equal to 0?
This is can you can you
0.5 minus 0.5, the jump.
Yeah. Okay. What about others?
Ma'am, please show the plot, ma'am.
Yeah, sure. I just okay. Plot is one of the thing. You have to practice it so that you can directly go with the function also.
0.6, no?
Oh, this is
Okay,
0.5.
0.5, man.
Oh, 0.5. 0.5. It's a jump, no?
Yeah.
So it's 0.5 plus that 0.1x minus 0.
Yeah. So
So it will be
what?
0.6.
Ma'am, this
Just take it. Probability x is equal to 0 is nothing but probability x less or equal to 0 minus probability x at equal to 0. Sorry, x less than 0, right?
Same like last time, no?
Yeah. So once you calculate this probability x less or equal to 0, this is nothing but f of 0, right?
Yes.
And at 0, it's taking some 0.5 plus 0.1 x. Here x is 0.
Oh, x is
Minus,
0. I
yeah.
made it 1.
Yeah. Minus probability x less than 0, it's again 0. So the answer for it is 0.5. Yeah.
The
Someone
first
was
one,
asking.
yeah, I was asking a
Okay,
doubt.
calculation.
If x is equal to 4, because it is in that range continuous, that's why you are taking this as 0.
Yeah.
Okay. But actually, in that the given range 0 to 5, it is we should apply this formula. But
No, you can't. Why you can't? Because this function is CDF. This is not a normal function. This is not a normal function. This f of x is nothing but probability x less or equal to 4. Okay. So here f of 4 means probability x less or equal to 4. But probability at a point 4 is a different thing. Okay, that means you are calculating probability at exactly at a point 4. But when you find f of 4 and put this value in like put 4 in this equation, then you will get what you will get. It is probability that your random variable is taking all the values less or equal to 4. Okay. Are you getting the difference between probability x is equal to 4 and x less or equal to 4?
Yes, ma'am.
Yeah.
Yeah. Though the person who has asked the
Yes,
question.
I was asking.
Yeah.
I no issue. But so the thing is, CDF by definition, it has to be in that x less than equal to some value. It cannot be at this specific.
Yeah.
For
CDF is cumulative distribution function. And
For-
whenever cumulative is there, it's not about a single point. You can't find cumulative kind of things for a single number.
Yeah.
You have to, you need some more numbers, more than one at least. Yeah.
So
Continue.
can you please scroll down now? Just wanted to see the questions and then.
Okay,
Just
these questions.
Yeah. So
Yeah,
GU
see here, I have done f of 4 here. At that time, we put the values, but when we were calculating probability at exactly 4, at that time it was 0. Yeah.
So at x0, it is not yet continuous. It is still random. Because it is piecewise continuous, there is a jump at x0. So that's why we are telling that this 0.5.
Yes.
Okay.
So the simple observation, like you can have a shortcut also. See, once the CDF is given there, Just first be careful whether CDF is given to you or PDF is given to you. Okay, if PDF is there, then there is a different story like this question. Okay, but if CDF is given to you, then your step number 1 will be, if possible, to then plot a graph. Okay, once you plot the graph, maximum things will be cleared. If your graph has a jump and they are asking probability at a particular point, like at x is equal to 0 or x is equal to 4, then just look at your graph and check whether your graph has jumped at that point. If your graph has jumped at that point, then just subtract the values. Okay, where 0 is included and 0 not included. The what we say, the the main real procedure is to subtract like that, f of 0 minus x less than 0. Okay, but I'm just telling you the shortcut. If you are come up with the graph from your question, okay, just take, if it has a jump, then you calculate these value like difference. If you're observing that okay, your graph is continuous after 0 and so on. If it is continuous and they are asking probability at a particular point, not an interval, okay, at a particular point, if they are asking you probability and you are observing that your graph is continuous onwards, then you can directly claim it 0. Okay, but if they are asking probability like x less or equal to 6, then what will you do? Then it's a different story. Probability x is equal to 6 is different.
Equal to 1. Less than equal to 6 is 1.
Yeah, and what about x is equal to 6?
It will be 0.
Okay. Are you getting the difference, like everyone?
Yes.
Okay. So like someone has told me to take the question so that there will be a conceptual clarity. So
Yes.
this is one of the shortcut. If you have a function, just draw the graph and then check whether your graph has a jump. If it has a jump, then at that point, the difference kind of things will come. You have to subtract the values and you will get the probability. But your graph is continuous there and they are asking probability at a particular point, the probability will be 0. Fine. Or you can say your graph is smooth, do not have jump, or whatever the language you use. Okay. At that time, the probability is 0. Otherwise, if you want to calculate CDF, then go to your function only. That will be more easy. Okay. So just be careful whether they are asking CDF or whether they are asking probability at a particular point. Okay.
Yes.
Okay. One more question I want to ask.
Yeah. How will the probability at a particular point look like? I mean, this is.
Sorry, what? How will it?
Is it
look like?
probability at a particular point? Na? I mean,
this probability x is equal to 0 is this one.
Okay, that is how it will look. No. That CDF, it will look. I mean, they will describe it like that. Huh?
Yeah. For CDF, they will ask you like, let's
0
say probability x less or equal to 0 or f of 0. Both are same, right? How do you write f of x? It is probability x less or equal to small x, right?
Small x, correct.
Yeah, small x. Yeah.
Okay, got it.
Okay, one more thing, one last question. Okay, it may be like, what is the probability at x greater than 3? How will you go for it?
1 minus probability less than or equal to 3.
1 minus x is.
What's the answer? Final answer? This is the, again, CDF is same.
1 minus x is less than.
Yeah, this is the question. Just tell me what is the probability that x is greater than 3. So now, if you answer it, that means all kind of question with this CDF is covered.
Can you please go back to the graph again? X is greater than 3. So, okay, it is falling in that range.
Okay, you can mute yourself. Okay, some topics are I will not be able to cover today. But in doubt session, we will start with that. Yeah.
Point 2.
Okay.
Point 2, ma'am.
Okay.
Point 2?
Yeah, fine. 1 minus, probability x greater than 3 is nothing but the 1 minus probability x less or equal to 3. This x less or equal to 3 is nothing but f of 3, right? That is 1 minus 0.5 minus 0.1 into 3. Yeah, it's 0.2. Okay, that's what all for today. So some topics are not covered today. We will cover it in doubt session. It will be on Tuesday. So I hope you enjoyed today's session.
Yes, yes, very much. Thank you so much.
Okay, thank you. Thank you, everyone.
Thank you, ma'am.
Yeah.
Thank you, ma'am.
Thank you.
Thank you, ma'am.